Hello, my name is Roy Simpson. I'm a professor of mathematics at Cosumnes River College in Sacramento, California. This is part C of a lecture on systems of equations, being an introduction to those, that is. And in this part of the lecture, we're going to go ahead and talk about some applications involving graphing systems of linear equations. Now, before I get too far into an example here, I do want to mention that usually, almost always in fact, you don't want to solve a system using the graphing method. It's a very weak method for solving a system of equations. However, since we're still kind of in the process of learning what a system of equations is, and we're still kind of graphing these out just to see what their solutions look like, we're going to try to do that here. We'll learn that it's not the best, especially, like I said, for applications. So here's an example. Yasau can afford to purchase 50x bushels of wheat if he can sell them at X cents per bushel. And the market will buy, or in other words, they will demand 2100 minus 20x bushels at X cents per bushel. Now part A of this and part B actually, both of these are going to just ask questions about what equation is what instead of graphing. So part A is just asking what is the supply equation. In other words, what is this person willing to bring to the market? And the supply equation, which I'll call S here, what the person's willing to supply, is 50x. That's what they're willing to supply. In other words, remember X is the number of pennies per bushel. So if the price is at 10 cents a bushel, then they're willing to bring to the market 50 times 10 or 500 bushels. Of course, if the price is higher, let's say 100 pennies per bushel, which is $1, right? Then they're willing to bring a lot more because they make more money. Of course, the more that a bushel costs, the less that people are going to demand, but still, it's the supply equation. The demand equation is actually the other one. What's demand? Well, the market is willing to demand 2100 minus 20x bushels. So therefore, if a bushel costs 10 cents, then the demand will be 2100 minus 20 times 10, or in other words, 2100 minus 200, which equals 1900 bushels. Okay. That's the idea. And what we want to really know is when does supply equal demand? This is an economic style question. So let's go ahead and graph both these equations. And one thing to note here is that even though the output variables are different, we can still graph them on the same axes. We will graph these as y's, in fact. It's a little bit easier to think of it that way. So I'll go ahead and try to graph these. Now the problem is I'm graphing by hand, right? And as I've mentioned previously, that graphing by hand can lead to really, really horrible results. My input variable is an x. My output variable is either an s or a d. So I'm just going to put both variables here. And I'll just make a table of values for the supply equation. Supply equation when x is 0, well, I supply nothing, right? If they're going to sell it, people say that I'll give you nothing for a bushel, then I'm not going to bring anything to market. But if they decide they'll give me, I'll say x is 10. If they give me 10 pennies per bushel, I'm willing to bring 10 times 50 or 500 bushels to market. Okay. On the other hand, for the demand, well, if the price is 0, the input value is the price. If the price is 0, people are going to demand a lot. In fact, they'll demand 2100 minus 0 or 2100 bushels. Beyond that, they probably just don't need more than 2100. And if the price is 10 cents per bushel, as I mentioned a moment ago, they'll demand 2100 minus 20 times 10, which is equal to 1900 bushels. Now it's important that when we build this table, and I'm calling this a table, it's not a table, but when I make these points, I think about the scale on my axes. My input numbers go from 0 all the way up to 10, and in fact I can plug in even more than that. So what I'm going to do is maybe make my inputs here go from, I'll go in steps of 5, so I'll call this 5, 10, 15, and so on and so forth. And my output variables, well, I can see the output variables are going to range from 0 all the way up to 2100, right? That's the highest output that I see amongst these. So going by steps of 5 here would be ridiculous. Even going by steps of 100 would be wrong. You might want to go by steps of maybe 300s. So like this would be 300, this would be 600, and so on and so forth. Now here comes the hard part. It's very difficult to graph these exactly, but we'll try. Supply equation. I know that when the input is 0, the output is 0. We have a point for that. And when the input is 10, the output is 500. So let me try to mark 500 out here. That's about a height of 500. So I'm going to try to connect these. I'll press pause and maybe use a straight edge here. All right, so now we'll go ahead, and I'll use a different color for this. We'll go ahead and try to graph the demand equation. For the demand equation, when we have an input of 0, everybody wants wheat. So they'll demand 2100. And when the input is 10, everybody still wants wheat. The demand will be about 1900. So let me try to graph this perfectly. It might not be so perfect. Let's see. It's probably right about here. Okay. Now I'll try to, again, draw a line through these perfectly. Something like that. Now remember, the purple's the demand equation, and the red, which I'll just kind of extend up a little bit, is the supply equation. And it looks as though the solution to the system, which by the way, I should have written it down as a system of equations. S is equal to 50x and D is equal to 2100 minus 20x. The problem with writing it like this is that when a casual observer comes in, they see these two different variables, they'll think, wait a second, you have 3 variables in this system, and there's no way you can graph them. So that's why I was kind of hesitant to do that. Often, if you want to really denote or designate to somebody that this is a true system of equations, you use y equals, just because that way you only have 2 equations, but you have 2 unknowns. A little known fact at this point is that if there is actually a solution to your system, you need the same number of equations as you have unknowns. Here we have 2 unknowns, so we have 2 equations. All right, if I look at this, it seems to me it might be at 26, input of 26, and the output might be around 1450 or maybe even 1500. That's what it looks to be, the solution to the system looks to be. Now, I'm not saying that's the exact solution, but it seems to me that that is the exact solution, just by visualizing it or looking at it. Now, there is a way to determine the exact solution. The way we can do that is to say, listen, I want to know when is, because this is really what the question is asking, part D, when is supply equal to demand? Well, replace the letter S with 50x, replace the letter D with 2100 minus 20x, and then add 20x to both sides, so you get 70x is equal to 2100. Divide both sides by 70, you get x is equal to 30. So this tells me that supply equals demand actually when x is equal to 30. And this is the tragedy of graphing by hand, is that it's never perfect. Okay, so it turns out the equilibrium price is 30 cents. If we charge 30 cents, if the market is willing to charge 30 cents, then I'm willing to bring, the amount I'm willing to bring to market is the same that people are willing to buy off of me. It matches up perfectly. So solving it algebraically has an incredible strength. Now, something I want to show for those who have a graphing calculator, I want to bring this up so that people can use their graphing calculators to see this, the solution of this. If you want to use a graphing calculator, you hit y equals. Remember, your menu up here for graphing is whenever you graph, you access the upper menu. I hit y equals, and I'm just going to type in 50x for the one equation. Hit enter, and now for the second equation, I'll type in 2100 minus 20x. If I just hit graph, I will not see, well, I'll see barely anything. So I need to adjust my window, and in fact, if you look at our graph, I'm going to try to adjust it to be kind of like that window right there. I'm going to go from maybe like a -5 in the x direction all the way up to a +40. So hit the window button here. You go from a -5, that's your x minimum. Your x maximum, we want that to be 40. Don't worry about the x scale for right now. The y minimum, I want it to be, well, let's go from -5. I just want a little airspace down below, that's why I put -5. All the way up to 2100. Actually, go to 2200. Just go a little airspace above. And hit graph. There's the first equation, that's the supply, and then there's the demand equation. You see they kind of do, this graph right here looks very similar to the graph we have on our, that we did by hand. However, a calculator is much better at graphing than I am. If you want to find out exactly where these meet, there's a couple ways you can do it. You can either hit the trace button here, and it puts on a little cursor, and you can move right or left, and you get really, really close to that point to find out where they meet. Problem is, it's very difficult to get an exact meeting point doing that. It's extremely difficult because it doesn't go by nice, easy steps. So another way you can do that is right above the trace button, in yellow lettering is the word calc, which means calculation. So I'm going to calculate their intersection by hitting the second button. Notice a little up arrow, that means I've hit the second button. And hit the trace button because I'm going to access the calculate menu. And here I see a bunch of options, but the one I want is intersect. I want to know when they intersect, so I'll select option 5. When you do this, it'll ask you, where's your first curve? Well, if you notice, I'm moving right and left on a curve, so I'll just say that's the first line. And here's the second line. You don't even have to be near the intersection. They just want to know, are these the two lines? So you do that, and then it says take a guess. That means move your cursor to basically where they meet and hit enter. And from here, it'll take a guess, and it turns out it guesses the correct solution, which is x equals 30. It says that the equilibrium price, or in other words, the solution, happens when x is 30. By the way, the output is 1500. So notice on my graph down here, I said it was 26 1500. It's because I graphed it by hand, and it was very difficult for me to do an exact graph. But it turns out it's actually 30, 1500. Let me close out of this. Essentially, this is all you really need to know about doing applications by graphing it, is that you don't want to do solve applications by graphing. Unless you have some type of fancy graphing utility or a graphing calculator, this is the weakest method for solving a system of equations. The next lecture in this entire lecture series will focus on how to solve systems of equations using an algebraic method called substitution, and another algebraic method called elimination or Gaussian reduction. They're both the same idea.